So here's the problem. Within the data center itself, from an engineering standpoint, from an operational standpoint, this is the problem summed up in one sentence. The facility is designed to support an IT configuration that it will never experience. That's the problem. You're designing something for a target that will never occur. So the design essentially is wrong from day one. And that puts, of course, all of us on our back foot as soon as the doors open on the data center, and now we're constantly trying to compensate for a wrong design. Now when I say wrong design, I don't mean it's anybody's fault, because the assumptions that go into the design are the best that people can come up with at the time. But this is the reality of the situation. So this is what happens from a capacity standpoint in the data center over its entire lifespan. So originally, there was a plan to fill out the data center in a regular way over a period of time, utilizing space, power, cooling, networking in an optimized way to the point where you reach your capacity goal in the room. And again, that could be total kilowatts, kilowatts per square foot, whatever the room was designed for. Then, in reality, the data center goes into operation, and a whole different set of IT equipment come in with different operational characteristics, different physical characteristics. They use the space, power, and cooling resources in a completely different way. And now you're dealing with, again, a wrong design, the impact of a wrong design from day one. And very often, the data center will never reach its capacity goal. And what we see as an engineering firm is, on average, enterprise, government, colo data centers, the most they can get out of the room is about 70% of the original intended IT capacity. They get stuck at, if it's a 1 megawatt facility, you can't get past 700 kilowatts without putting IT equipment in danger, without incurring risk because of this problem. So this is what we're calling the elephant in the room. A little Photoshop effort there. So what is the cost of this on a per square foot or per data center basis? If you look at, again, a comparison between the plan, here's the plan utilization of capacity over time, all the way up to the intent. And then you overlay that a typical actual utilization of capacity. So then, somewhere before the intended end of life, the data center hits that glass ceiling. It's not safe to go beyond that, and all of this capacity is lost. There's even a loss of lifespan, so you have to raise capital earlier than planned, start a new data center build, or move into another space. And if you compare the budgeted cost to the actual cost, when you factor in this lost capacity component, it almost doubles on a per megawatt basis. So these numbers were pulled from a report done by Uptime Institute, where they were estimating total cost of ownership for a data center. And their estimate at the time was about $8.3 million per megawatt. I believe that was tier 3 level facility. When you factor in our own numbers, and what we see in the industry as far as the average amount of lost capacity, that number goes up to about $15 million per megawatt, almost doubles. It's a very, very expensive problem.